Assalamu alaikum bachcha log. So this right here is May June 2014. Ramzan hai, raat ke 2 baj rahe hain, and I gotta wake up at 4 for suhoor as well. Okay, so let's wrap this up as soon as possible. So student investigates floating blah blah blah, mark label length L of the rod above the water. So of course this right here is our length L. ठीक है जी. This right here would be our length L. Explain why is it difficult to measure L. So why is it difficult to measure length L? Of course, now जाहिर सी बात है, rod is in water, so it's not going to stay stationary. Anything in water you would have noticed कि वो बार बार जो है वो move हो रही होती है. So we are going to say because it's in water, because it is in water, it moves continuously. And you can also say कि भाई because it's in water तो ज़रूरी थोड़ी है कि it stays vertically like so. हो सकता है वो थोड़ा सा टेढ़ी हो जाए, something like that. It bobs up and down, so on and so forth. ठीक है, तो any one of those reasons would be just fine. Describe a method to measure L accurately. तो उसका आंसर जो है should be fairly simple. आप क्या करेंगे, you will mark the level of the water. ठीक है, आपने level of water mark कर दिया. अब आप ये करेंगे कि you take the stick out and you measure the length. So you're going to say mark the level of water. ठीक है, take the stick out and measure. अब जाहिर सी बात है accurately है तो you cannot use a ruler, so measure using, because it's generally seems like it's going to be a longer length, so we are going to say a vernier caliper. ठीक है, इसके अलावा भी अगर कोई सेंसिबल आंसर आपके जहन में आ रहा है तो आई थिंक दैट शुड बी जस्ट फाइन. ठीक, एक और तरीका ये हो सकता है कि यू मेजर ऑल द वे फ्रॉम हियर टू हियर, पूरा का पूरा डिस्टेंस जो है वो आप मेजर कर डालें. उसके बाद आप वाटर लेवल जो है वो निकाल के उसको मेजर कर लो और फिर सब्ट्रैक्ट कर दो. यू कैन डू दैट एज वेल. यू वॉन्ट हैव टू टेक द स्टिक आउट. ठीक है, तो एनी वन ऑफ दीज मेथड्स would suit our purposes just fine. Student increases the number of rubber bands. जाहिर सी बात है, rubber bands ज़्यादा होंगे, weight ज़्यादा होगा, it's going to weigh more, and hence the rod is going to keep on going down until it sinks essentially. So blah blah blah. Measure. So plot the graph L centimeters on y and n on the x-axis. ठीक है, let's do that. Let's pick this up. ठीक है, एंड फिर इसको जो है अब हम क्या करेंगे, fairly simple. Let's zoom out a little more. Yeah, perfect. Let's put this here. Acha. Now let's go from start your graph from origin, draw a line of best fit. So origin से start करना है, line of best fit चाहिए, cool. Now x-axis and y-axis. तो x-axis पे you've got n all the way till 9. हम divisions देख लेते हैं. So 1, 2, 3, 4, 5, 6 and 7. Now there is no way you can fit 9 readings in 7 divisions. If we use 1 division as 1 unit, you can do a maximum of 7. So you have no choice but to go with 2 divisions is 2 units. Okay, it's still going to be more than half, but not a lot more. All right, so this is going to be 2, 4, 6, 8, 10, 9 यहाँ तक आएगा. ठीक है ना, तो it's still more than half, but that fulfills our purpose. All right, so on the y-axis you're going to go all the way till 9 again. Y-axis पे भी आपको 9 तक जाना है. How many divisions do we have? 1 2 3 4 5 6 7 8 9. So over here we have enough divisions for one large division is 1 unit. So we are going to go with 1 2 3 4 5 6 7 8 and 9. अब हम पॉइंट्स प्लॉट करना शुरू कर देते हैं. 1 पे इट्स 8.5, so 1 पे इट्स 8.5. 2 पे 3 पे it's 6.8, so 3 that's 2 that's 3 पे it's 6.8. all right. 5 पे it's 5.1. अच्छा, it's 2 units. My bad. So 1 is going to be here. That's 8.5. So this right here is 1 and 8.5. 3 is going to be over here. So 3 and 6.8. Right. Then you've got 5 and 5.1. So 5 is going to be somewhere over here and 5.1. Okay. So that's going to be 5.1. 7 and 3.5. So 7 is going to be here. The 7 and 3.5 smack in the middle. And then you've got 9 and 1.6. I'm going to have to move this table. थोड़ा सा ऊपर लेके जाते हैं इसको. ठीक है. Then we've got 9 and 1.6. So 9 and 1.6 goes over here. All right. So we zoom out a little. And then we're supposed to draw a line of best fit. ठीक है जी. So we are going to draw a line of best fit. I'm guessing goes slightly here. Oopsie daisy. So we are going to have to. Yeah. अच्छा जी. इसको हमें extend करना होगा. So we extend it. Now this seems like a good line of best fit to me. The reason being, this point is on the line, this point is on the line, this point is almost on the line. This point right here is slightly above, and this point right here is slightly below. Okay, this seems fairly correct. All right. Do we have any questions on the previous page? No, we don't. Describe the relationship between L and N. So we've got a negative relationship, negative gradient, है ना? So you increase the number of N, the number of rubber bands, and your length above the water surface decreases. So negative relation, negative linear relation. Linear लिखना ज़रूरी होगा और उसका reason ये है कि straight line है, तो linear relation है. So we are going to say that as N increases, L decreases. So saying that should be plenty. ठीक है ना? इतना लिखना जो है वो काफ़ी होना चाहिए. ठीक है. Cool. अच्छा, use the graph to estimate the smallest number of bands needed to sink the rod. Sink the rod means आपकी height जो है वो 0 होनी चाहिए, and at 0 you've got exactly 11. अगर थोड़ा कम भी होता तो हम round off करते. You cannot use half or a non-integer number of rubber bands. ठीक है. Explain why is it important to use identical rubber bands so that they weigh equal. Identical rubber bands will weigh equal. Hence a constant amount of increase in weight of the rod, of the rod. ठीक है जी. Alright. तो खैर वो 2 बजे वाली बात जो है, I just I didn't mean to mention it, but again, जिस तरह से me as a teacher, I'm dedicated. I don't have time in the morning. I don't have time in the afternoon to make these videos. The only time that I have is at night before suhoor. तो आपको जो है उतनी ही डेडिकेशन के साथ पढ़ना भी चाहिए बेटा. ठीक है. Question number 2. State quantity measured using an ammeter. That's current, of course. Explain why is it important for an ammeter to have a low resistance. Ammeters are usually in series. Usually नहीं, they are always in series actually. And अगर series में आप ज़्यादा resistance लगाओगे तो current बहुत ज़्यादा drop हो जाएगा. So ammeters are in series, hence large resistance would result in large current drop, या large decrease in current, large current drop. We can also say potential difference, क्योंकि अगर आप, so let's say for example, if in the circuit you have a large resistance connected in series, that will take away potential difference from everything else, right? So hence we cannot have a large resistance in a series circuit. That's not part of the circuit itself. Now the ammeter is not a part of the circuit, right? It's just there to measure the current. Alright, figure 2.1 shows analog, state the reading. So alright, so 0.1, 0.2, 0.3, 0.4, 0.5. So each large division is 0.1 units, so each small division would be 0.02. ठीक है, तो ये 0.06 होगा, 0.6 and 0.7 होगा. So of course 6.2, 6.4, 6.6, अच्छा 6.6 और 6.8 के बीच में. So I'm guessing this right here would be 0.67 amperes. ठीक है, it's an ammeter, it's not a micro ammeter, तो 0.67 amperes होगा rather than 0.67 milliamperes. ठीक है. I hope that makes sense. अब यहाँ पे I'm guessing that probably your marking scheme would need an exact value. An approximate value like 0.66 or 0.68 will not work. ठीक है, so please be careful over here. School has both digital analog, so just one advantage of digital, of course. So बहुत सारे बच्चे यहाँ पे क्या लिखेंगे? They are going to write it's accurate. Now, saying that it's more accurate, a digital would be more accurate is an umbrella term. Don't use umbrella terms. ठीक है, you need to be very very specific. तो इसमें आप क्या कह सकते हैं? इसमें आप ये कह सकते हैं कि भाई एनालॉग में पैरेलैक्स एरर होता है. There is a mirror to avoid that in an ammeter, but still जाहिर सी बात है, it's going to be easier. So you can say that it's going to be more accurate in a sense that it might give you, because you can manage the range of the ammeter. A digital ammeter can have variable range. तो आप रेंज को जो है वो इस तरह से मैनेज कर सकते हैं कि यू आर गोइंग टू गेट अ मोर एक्यूरेट वैल्यू बिकॉज यू कैन मैनेज द रेंज. सही है. अब लेट्स से फॉर एग्जांपल अगर मुझे 0.3 एम्पेयर्स मेजर करना है, मेरे पास एम मीटर है 0 से लेकर 10 एम्पेयर्स, तो जाहिर सी बात है उसके अंदर ऑलमोस्ट कोई डिफ्लेक्शन ही नहीं आएगी, राइट? Likewise, if let's say for example you need to measure 2 amperes, you are using an ammeter from 0 to 1. Of course you won't be able to measure 2 amperes, but in a digital ammeter you don't need to switch ammeters. It becomes very simple. एक switch होती है उसके अंदर, उसे आप range जो है, you can easily change the range of a digital ammeter using a simple switch. सही है. So you are going to specifically state why is it more accurate, because no parallax error. And you can also write no need for ammeters with many ranges. You can just have one ammeter and then change the range on that digital ammeter. So can easily change range. All right, so we can easily change the range of a digital ammeter. Okay, cool. Explain why all the ammeters should give the same reading. Current is the same in a series combination. In series, current stays the same throughout the circuit. In series, current stays the same. ठीक है, there are no point nodes के करंट थोड़ा यहाँ पे जा रहा है, करंट थोड़ा यहाँ पे जा रहा है, anything like that. There are no nodes or junctions or whatever you want to call them. No junctions आप या no nodes लिख दें. जो भी आपको यहाँ पे समझ में आ रहा है. No nodes या junctions, whatever you want to like, whatever you like. Suggest a reason for the slight differences in the three readings. अच्छा, तो ये 3 ammeters जो हैं अच्छा कह रहा है ऊपर the ammeters give slightly different readings. तो उसके बहुत सारे reasons हो सकते हैं यार. A different company ammeters measure differently, calibration change हो सकती है, zero errors हो सकते हैं. So I'd like to go with zero error. And difference in calibration. Difference in calibration. ठीक है. So any one of these answers would do just fine. Question number 3 पे चले जाते हैं. Alright, so we need to draw things out. Let's hope it does not ask to measure length. It does. Okay, chalo, cool है. Let me just open up the marking scheme because again, we will not be able to measure the length. So just give me a second. I'll be right back. Okay. Experiment is carried out to investigate reaction, refraction, blah, blah. Draw lines to represent the normal at P. अच्छा, मज़े की बात यह है कि मेरा सॉफ्टवेयर जो है जिस पर मैं अभी काम कर रहा हूँ, it gives me exact vertical lines, so I don't have to pull out a protractor to get that. Okay जी, ये आपकी आ गई exactly एक normal line. ठीक है, so you've got a normal. Usually होता ये है कि वो normal आगे extend करने को बोलेगा. Most of the questions like this, it will ask you to extend. We've done this question before. ठीक है, तो ये question मेरे ख्याल में दूसरी तीसरी बार repeat हुआ है. And again, questions like these will repeat. So you might as well just expect in advance what the question wants you to do. Refracted ray. So I'm gonna have to pull out my I need to get my protractor to do that. There's my protractor. ये आ गया protractor. Too big, too big, too big, too big, too big. अच्छा जी, अब इसको हमें थोड़ा सा जो है, ओके नहीं, slightly, oops, almost ठीक है. I'm guessing this will do just fine. So the question says, मेरे ख्याल में 24 degrees देखा था. Yes, it says 24 degrees. So I'm gonna have to mark 24 degrees over here. So 20 and then 4 is right here. Of course, so oopsie daisy. Please. Yeah. So I might as well just make it. I guess red wali jo hai already hai. Yes. So 24. So 10, 20, and then 24 would be right side. ठीक है जी, let's get rid of this and draw a line. From here, इसको भी आगे हम extend ही कर लेते हैं. Okay, so we've got the refracted ray. अब देखते हैं question क्या बोल रहा है. So normal हो गया, refracted ray हो गया. The lower face of the block is labeled XY. So let's just put those labels already there. Continue the normal like I said. It will ask that. So this point right here is A. वो refracted ray को भी continue करने का बोलेगा. Continue the, अच्छा, so it says that as well. ठीक है, so this right here is going to be point B. And then we've got measure AB and PB. Where's AB and PB? All right. Yeah, so I'm gonna have to use the marking scheme for that. Marking scheme कह रही है कि AB की वैल्यू 2.8 है एंड जो वो है PB that's approximately 2.6.9. So ठीक है, it looks like that as well. So according to the question, according to the marking scheme, this right here is 2.8 and this is 6.9. Plus or minus 0.1 centimeters. तो बहुत ज़्यादा आगे पीछे भी नहीं हो सकता. So your range is in between 2.7 and 2.9. Over here your range is in between 6.8 and 7. ठीक है. Continue the incident ray. Okay. We can do that. थोड़ा सा पहले से बनाते हैं so we know that it's accurate. Yep. ठीक है, it is. अबे यार, come on. Okay, so this right here would be point C. Right? Come on, please don't make me do all this back and forth. AC and PC. So A से लेके C, so this length right here, and P से लेके C, so this length right here. Let's see what the marking scheme says. The AC should be 5.3 and PC should be 8.2. Again, a plus minus 0.1. So your range is from 5.2 to 5.4 and 8.1 to 0.1. अब जाहिर सी बात है आप अपनी when you're going to draw this, so your answer should be this right. Oops, sorry. 8.1 to 8.3. My bad. This is where your answer must lie. ठीक है, theory suggests that the refractive index is given by the ratio AC. What's AC? That's 5.3 into PB. That's 6.9 divided by what? Divided by AB, which is 2.8, multiplied with what? PC, which is 8.2. All right. Give an answer to a suitable number of significant figures. ठीक है. 2 या 3 should be just fine. Let's calculate this out. I'm gonna need a calculator. Where's my calculator? Where's my calculator? There we go. Acha ji, so you've got 5.3 times 6.9 divided by 2.8. No, it's 2.8. 0.8 and then further divided by 8.2. So 1.59 answer आ रहा है. So 1.59 आंसर है. गिवन के आपने ऊपर जो है सारे आंसर्स 2 SF के ऊपर दिए हैं, तो yeah, so I think I'm gonna go with 2 SF as well. 1.59 नहीं लिखेंगे, it's actually going to be 1.6. My bad. 1.6 is going to be your answer. On figure 3.1, draw a line to represent the ray of light that emerges from the block. Label this line L. अब जाहिर सी बात है इसका एंगल जो है वो एग्जैक्ट होना चाहिए. तो आप यहाँ से यू आर गोइंग टू, डू वी हैव द एंगल डायरेक्टली 30-ish 40. ठीक है. सो वी आर गोइंग टू ब्रिंग बैक और हैंडी प्रोट्रैक्टर. ठीक है. All right. We're going to move it. Exactly 90 degrees पर मूव हो गया. सारी सी बात है आपको यहाँ पे नॉर्मल बनानी पड़ेगी एट बी. ओके ओके. अबे यार So I'm gonna have to bring it slightly. Yeah. So this is the best I can get. So 40 degrees would be somewhere over here. Yeah, 40 degrees line hai. So like this. We are going to get rid of this. And we are going to draw a line from B passing through this point like so. So this right here would be your 40-degree line, the emerging ray. ठीक है, एंड इसको लेबल क्या करना है, क्वेश्चन क्या बोल रहा है, लेबल दिस लाइन L. Cool, we can label this line L. All right. Experiment carried out, blah blah blah, shows full stack, taking measures, state determine the average volume of a microscopic slide, state clearly any measurements taken and show how the volume is calculated. All right, determine the volume of a microscope slide. ठीक है, वॉल्यूम निकालने के लिए हमें क्या क्या चाहिए होता है, वॉल्यूम निकालने के लिए, बिकॉज दिस इज अ रेक्टेंगुलर और अ क्यूबॉइड, so your volume is going to be equals to length times the breadth times the height. Again यहाँ पे आपकी length और breadth जो है वो बहुत carefully and exact होनी चाहिए. So according to the marking scheme, this length turns out to be 7.6, this width or breadth turns out to be 2.6, and then this stack right here is exactly 1 centimeters in length. ठीक है. So because that's the case, so in this case we are going to go with length 7.6, width 2.6, but height जो है वो हम 0.1 रखेंगे, because 1 centimeter was the height of 10 of these slides, right? So yeah, that's what it's going to be. अब इसको जो है हम मल्टीप्लाई करके, क्योंकि क्वेश्चन कह रहा है कि 2 SF पे आपको आंसर चाहिए, so let's multiply this. So this is going to be approximately 0.25, 1.9-ish. तो 2.0 आपका approximate answer होना चाहिए. Slightly more than 1.9, तो I'm just gonna go with 2.0, just for the sake of it. ठीक है, सेंटीमीटर है या सेंटीमीटर है, so सेंटीमीटर क्यूब्ड. ऑल राइट, यूनिट लिखना ज़रूरी है, मत भूलिएगा, 4 मार्क का सवाल है. स्टेट एनी मेजरमेंट्स, ठीक है, तो वो मेजरमेंट्स हमने शो कर दी, लेंथ ब्रेथ और हाइट. स्टेट हाउ द वॉल्यूम इज कैलकुलेटेड, फार्मूला लिख दिया, और या वी शुड बी गुड. ठीक है भाई. ओके, एक्सप्लेन व्हाई अ स्टैक ऑफ 10 स्लाइड्स इज यूज्ड रादर देन 1 स्लाइड. तो वही है पिके भाई, माइक्रोस्कोप स्लाइड इज़ वेरी थिन, और उसकी वजह से हम जो है वो स्टैकअप कर देते हैं, सो दैट इट बिकम्स ईजियर टू कैलकुलेट. हमारे पास स्केल है, वर्नियर कैलिपर है, क्या है, show stack full width, by taking measurements determine the average volume, state clearly any measurement show and how the volume is calculated. Yeah, but still the answer stays the same. We are not given any particular name of an equipment that is used, but still आपका आंसर जो है वो सेम रहेगा कि भाई आपकी स्लाइड्स जो है वो बहुत पतली होती हैं, सो इट जस्ट मेक्स श्योर दैट वी आरंट मेकिंग एनी एरर्स. तो डिवाइड बाय 10 हो जाएगा, तो आपकी एरर भी डिवाइड बाय 10 हो जाएगी, सो परसेंटेज एरर रिड्यूस हो जाएगा, तो वही आपका टिपिकल जो आंसर है. Then what do we have? We can also say कि मेरे ख्याल में यही आंसर हो सकता है, other than कि let's say for example अगर हम assume करते हैं कि भाई maybe the glass slides are different in thickness. ठीक है, so maybe we can say that glass slides are different in thickness, or we can say too thin to measure one. सही है. स्टेट एनी एडिशनल इक्विपमेंट नीडेड टू फाइंड द डेंसिटी. डेंसिटी के लिए मास चाहिए, सो यू नीड एन इलेक्ट्रॉनिक बैलेंस. ठीक है जी, आई डोंट सी एनी फर्दर क्वेश्चंस. ठीक है, so we are done with May June 2014. Inshallah I'll see you in the next one, kids. Take care. Bars out.